This program is brought to you by Stanford University.
I'd like to start with a question, and the question is, what is desire? Now, all of us have intuitions, I think, about the answer. But I'd like to argue today that this is not just a philosophical question. This is a scientific question. And specifically, what I mean is that we can ask questions like, what are the neural substrates that support desire? When does it happen? Under what conditions does it emerge? How does it work? And is it good for anything? Is it good for making decisions, for instance? And is it also important for our well-being? When I think of desire, this is the first image that comes to mind for me. How many people have the same phenomenon? Okay, well, I'll try to explain this. This is a picture that was taken about 50 years ago, and it was taken in the lab of Donald Hebb at McGill by a couple of, a grad student and a postdoc at the time, Jim Olds and Pete Milner. And what they'd done, they'd stuck an electrode down in the brain. They were trying to wake the rat up. They weren't having very good success. But they did notice something interesting, which is that the rat kept returning to the corner of the cage in which it was stimulated the day before. So Olds got an interesting idea. He said, what if we let the rat stimulate its own brain? What will happen? So that's what he did. He rigged up a lever here, you can see. And you can see the electrode going into this rat's brain. And he just let the rat press the lever. So the rat did that for a while. And it kept doing it. It kept doing it. Kept on doing it. It kept doing it. So in subsequent experiments, they found that this was a very attractive activity for this rat. The rat would rather do this than sleep, eat, drink, or have sex. So they thought, they were very excited, and they thought, oh, we found the reward circuit. And you know, there's something to that. Well, what I'd like to argue today is they couldn't have conceived of the importance of this finding 50 years later when we're talking about sophisticated decisions involving finances, which we're all thinking about these days, and also mental health. And the reason we have something more to say about this 50 years later is because of advances in technology. And I think basically we have a method, functional magnetic resonance imaging, which was developed in 1993, which gives us better temporal resolution. We can see changes in brain activity in living, breathing humans on the order of seconds. Better spatial resolution. We can see activity in voxels, or little pieces of the brain the size of 1 millimeter or 2 millimeters cubic. And most importantly, deep resolution. So we can go below the cortex, where other methods like EEG that have better spatial temporal resolution can't, and see what's going on in these deep circuits of the brain. And this is very exciting for many people, and many of the advances have occurred over the last 10 years, and I'm just going to talk about a few of them today. This just shows a structural MRI. This has been around for a while, but when we scroll back through the brain from back to front, we're going to see a map, a yellow map, superimposed, that illustrates how you can send things into the brain and correlate activation in those areas with whatever happened. So when we wanted to probe these areas in humans not so long ago, we were trying to come up with something that was very motivating to humans. And we tried many different stimuli. We tried pictures of attractive people. We thought about using juice, the kinds of stimuli that you would use in animal experiments. And we finally came up with money, because most people would work for money. It was reversible, so you could give people money and take it away, and you could actually scale the amount of money. So it makes a very handy experimental tool. So the kind of experiment that we did, let's imagine you're in my magnet. You're sitting there, you're looking through a little periscope at the screen, and you can respond with a button press. You would see something like this, a cue, a very simple shape, and then you would wait 2 seconds or so, and then you would see a target presented very rapidly. And your only job during this task is to press the button when that target comes on and before it leaves the screen. Now, depending on the cue that you saw, you might make money or avoid losing money. So this is the structure of the trials of this task. And as you can see, the trials are set up so that we can separate here the anticipatory interval when you're waiting to find out whether you can respond and make money or respond and avoid losing money from the outcome. And the temporal resolution of fMRI allowed us to look separately at what was going on in the brain during this period and during this period. And what we saw, just to cut to the data, is that when people anticipated making money, we saw increased activation in a region not far from the region that Olds and Milner stimulated in 1954. The nucleus accumbens. This is a subcortical region. It's conserved across the mammalian line and probably even further back. You can see that it's subcortical here. So this is a brain with a cutaway here, here, and here, with a chunk taken out. You can see deep into this nucleus accumbens area. You can also see that less is happening in the cortex. And the important point is that when people anticipated loss, we didn't see the same scaled activation in this region. We saw activation in other regions, and some of them I'll mention. If you take the activation out of this area, plot it over time, corresponding to different phases of the trial, what you see is that during this anticipatory phase, this first blue line, there's less activation when you anticipate making $0, 20 cents, $1, and $5 is at the top. And this is occurring before you respond with the button press. And certainly, the activation is almost diminishing by the time you actually make the money. Now, this is also a plot indicating that it's not just, this isn't just the money spot, okay? So let's say I'm anticipating making $5, and Brian Wandell's anticipating making $5. And maybe Brian thinks making $5 isn't that exciting, because he's already rich. But I'm very excited. I can buy a latte or something like that. So I would be one of these people over here. Each one of these dots represents a person who saw the $5 cue and has lots of activation in my nucleus accumbens. And Brian might be over here, not so excited about making the $5. So even controlling for the amount of money that you think you're going to make, we can account for variance of activation in this area depending on how excited you were about making the money. Okay, well, that's all well and good. And you may or may not be interested in emotion, as I am. But you might say, what is this signal good for? You see something during anticipation. What can you do with that? Well, we've looked at this in two areas. One is a sort of a short-term type of prediction, and that is looking at investing and purchasing products. The second area that we've looked at this is in the context of mental health, which one could reframe as chronic biases in some of these components that go into decision-making. So I'll talk about the decision-making first. So in our investing experiment that I did with Camelia Kunin at Northwestern, she's now an assistant prof there, people saw three options, 2 stocks and a bond. Then they saw this word choose, and they could choose one of those options. Then they waited and saw how much they made. Now, in this case, the subject had just chosen stock T and had made $10. And then people see what would have happened if they would have chosen the other option. Now, today, all I'm going to focus on is what is happening in this anticipatory period in your brain, and can it help us to predict what you're about to choose? We should be able to use nucleus accumbens activation to predict the people who are more likely to take risks, because they see the upside of that risky proposition more. And that activation in another area of the brain, the anterior insula, would help us to predict the opposite choice of the bond, running away from risk. And that's essentially what we saw. If people had more nucleus accumbens activation prior to choice, they were more likely to choose that stock. And activation in this other region predicted that they were more likely to choose the bond. Now, many of us are not investors, or at least would like to avoid investing, myself included, but most of us shop. This is the most ubiquitous economic decision out there. And so can we use activation in these regions to actually help predict what people will buy? In this experiment, if you're in my magnet, you might see this first, a product, and then see an associated price, and then be given the opportunity to either buy that product at that price or not. We did this for 80 products, and we gave people money before they went in the magnet, so we gave them $40. And we said 2 of these trials will count for real. So if you buy the product, you'll pay us, and we'll ship the product to you. Otherwise, you keep the money. We wanted, again, to see what was happening in these regions when people were considering the products and these prices. And here's what we saw. Here's our old friend, the nucleus accumbens. When you correlate people's preference when they see products with activation in this area, you see a nice correlation. And in this other area, we're seeing something different. This region seems to respond to prices that seem exorbitant and seems to predict that you're not going to buy something. These plots are extracted from these 2 regions and represent trials in which you're about to buy a product or you're about to not buy a product. And what you see is a bump up in activation in this nucleus accumbens area right when people see the product, long before they're going to make a choice, which continues. What you see in the insula, conversely, is when people see a price that they think is excessive, you see an increase in activation, and that predicts they're not going to buy the product. Okay, but that's all nice, and you know, maybe if you're interested in economic decision-making, it's exciting. It's definitely exciting to me. It suggests this activation is consequential. However, we're also concerned about well-being and health, and I'm going to present you one of the more dramatic examples we've seen of differences in brain activation in these areas and how those differences can be remedied. The examples from schizophrenia. Why schizophrenia? Well, many schizophrenics report a deficit in desire, if you will. This is called negative symptoms in psychiatry. It includes anhedonia and a lack of motivation. And some medications that schizophrenics take can make this worse. So the so-called typical neuroleptics can exacerbate these symptoms. Other medications in psychiatry, known as atypical neuroleptics, tend not to make these symptoms worse. So in collaboration with colleagues in Germany, in Berlin, Andreas Heinz and his group, we've actually looked at just expectancy in the brains of schizophrenics and healthy controls. And what we see is with Germans is the same thing that we saw with Americans. That is to say, when they think they're going to make money, their nucleus accumbens activates. So that's all well and good. But what about schizophrenics? When we look at their brain in the same task, we're getting the same behavior, they're making the same amount of money, we see very little activation in this area. There's a blunting of this activation, and this blunting is correlated with the schizophrenic's self-reported lack of desire or negative symptoms. So what we can do then is, for those schizophrenics that are on typical neuroleptics, we can actually switch them to the atypical neuroleptics and run them in the same experiment again and look at what's happening. And what happens is their negative symptoms are alleviated, and we start to resurrect the signal in this part of the brain. So this suggests that these tests aren't just for economic fun and games, that they can actually be useful as probes of symptom profiles in mental health issues. We think that anticipation is a powerful evoker of desire, and we think that brain activation can reflect that. And we think that brain activation, we can use it actually to predict financial choice, but beyond that, we can actually use it to index some symptom profiles in mental disorders. And the implications are that we'd like to build a componential and dynamic theory of decision-making that can account for the wide disparity of decisions that people make, both when they're being rational or reflective and when they're not. And we'd also like a better remapping of disease onto symptom profiles so that we can address those symptoms better. Thanks.